The introduction of solid-state drives was a big breakthrough in data storage. Unlike old hard disk drives that use spinning disks to store data, SSDs use special memory chips with no moving parts. This change makes SSDs faster, more durable, and more energy efficient. In this video, we'll explain what SSDs are, how they work, and how they've changed everything from gaming to data centers. An SSD, or solid-state drive, is a type of storage device used in computers. This storage medium, using memory chips, allows data to be retained even in the absence of a power supply. This flash memory is made up of memory cells that can be programmed to store information using transistors. SSDs replace traditional hard disk drives in computers and perform similar basic functions to those of hard drives. But SSDs are significantly faster in comparison. With an SSD, the device's operating system will boot up more rapidly, programs will load quicker, and files can be saved faster. A traditional hard drive consists of a spinning disk with a read-write head on a mechanical arm called an actuator. An HDD reads and writes data magnetically. The magnetic properties, however, can lead to mechanical breakdowns. By comparison, an SSD has no moving parts to break or spin up or down. The two key components in an SSD are the flash controller and flash memory chips. Flash memory is called flash because of its ability to create or erase a block of data in a flash, or very quickly. The term was coined by Dr. Fujio Masuoka while working for Toshiba in the early 1980s. The configuration of flash controller and memory is optimized to deliver high read and write performance for sequential and random data requests. SSDs are used anywhere that hard drives can be deployed. In consumer products, for example, they are used in personal computers, laptops, computer games, digital cameras, digital music players, smartphones, tablets, and thumb drives. They are also incorporated with graphics cards. However, they are more expensive than traditional HDDs. Businesses that need to process a lot of data quickly have fueled the development and adoption of SSDs. Because SSDs offer lower latency than HDDs, they can efficiently handle both heavy readings and random workloads from the linked computers on the network. They can also help to alleviate boot storms with virtual desktop infrastructure or inside a storage array to store frequently used data locally using a hybrid cloud. That lower latency stems from the ability of a flash SSD to read data directly and immediately from stored data. So how do SSDs work? SSDs process information differently from mechanical hardware drives. They do not have a read-write head, which acts like a needlehead of a record player, nor do they have high-speed spinning platters, what would be the records of the previous analogy. Instead, reading and writing operations are performed electronically, which means that they can access and retrieve information extremely fast as electricity can move. An SSD reads and writes data to underlying interconnected flash memory chips made out of silicon. Manufacturers build SSDs by stacking chips in a grid to achieve different densities. These chips use floating gate transistors, FGTs, to hold an electrical charge, which enables the SSD to store data even when it's not connected to a power source. Each FGT contains a single bit of data, designated either as a 1 for a charged cell or a 0 if the cell has no electrical charge. Every block of data is accessible at a consistent speed. However, SSDs can only write to empty blocks, and although SSDs have tools to get around this, performance may still slow over time. SSDs use 3 layers of memory: single-level cells, SLCs, multi-level cells, MLCs, and triple-level cells, TLCs. Single-level cells can hold 1 bit of data at a time, 1 or 0. They are the fastest and most durable, but they are also the most expensive. Multi-level cells can hold 2 bits of data per cell and have a larger amount of storage space and the same amount of physical space as a single cell. However, multi-level cells have slower write speeds. Triple-level cells, TLCs, can hold 3 bits of data in a cell. Although triple-level cells are cheaper, they also have slower write speeds and are less durable than other memory types. Triple-level cell-based SSDs deliver more flash capacity and are less expensive than multi- or single-level cells. Due to having 8 states within the cell, triple-level cells may experience bit rot, or data degradation and loss over time. When were solid-state drives introduced? Just a few decades ago, SSDs were an unknown device. At this time, data on computers was stored primarily on mechanical hard drives, otherwise known as HDDs. With all the moving parts working together inside HDDs, they were the likeliest computer hardware component to fail. As a result, research for a better storage drive began, which led to the development of SSDs. Earlier experiments with SSD-like technology began in the 1950s. They used them in first-generation computers through two similar technologies: card capacity read-only storage and magnetic core memory. However, these two solutions went out of style in the 1950s and 1960s, with the growing popularity of cheaper storage components like drum memory. As technology is constantly evolving, by the 1970s and 1980s, SSDs were back on the scene, and they were being used in supercomputers. However, the technology was very expensive and the storage capacity was small at only 2 to 20 megabytes considering the high price tag. So it was mainly used in the military and aerospace sectors until the 1990s when it made its way into consumer devices. In the early 1990s, hardware innovations caused the price of SSDs to drop, but the lifespan and size of the drives were still an issue. SSDs had a lifespan of only about 10 years. By 1991, commercial flash-based SSDs entered the market, the first being released by the company SanDisk. They were made with enterprise multi-level cell flash technology, which enhanced write cycles. In the late 2000s, SSD technology improved significantly, allowing them to last for decades and work at incredibly fast speeds. In 2003, the company Transcend introduced cheap flash SSDs with a connector that plugged the SSD hard drives to computers. However, it wasn't until 2006 that Samsung mass-produced flash SSDs with a 32GB storage capacity. In 2009, 3 years later, PCZ Technology introduced SSDs with a large 1TB storage capacity. 3 years after that, in 2012, Virident Systems developed an even larger SSD with up to 2.2 TB of storage. Why SSDs are better than HDDs? Now let's come to the battle of storage devices. While traditional hard disk drives are still sold and used by many data centers and customers, more and more businesses and individuals are switching to solid-state drives. Here's why. Speed. Since it doesn't have moving parts, a solid-state drive can read data 10 times faster than a hard disk drive and write 20 times faster. Also, while a standard solid-state drive's copying process is 500 megabytes per second, traditional hard disk drives range between 30 megabytes per second and 150 megabytes per second. Lifespan. Because they don't have moving parts, solid-state drives have a longer lifespan than HDDs. HDDs typically last around 3 to 5 years on average due to wear and tear that shorten their lifespan. Solid-state drives can last up to 10 years or more. Energy efficiency. Due to an HDD's dependency on lots of mechanical operations, it's a power-hungry storage. In contrast, solid-state drives are more energy efficient and consume less power, prolonging battery life. No overheating. SSDs are more heat resistant, whereas HDDs tend to overheat, compromising the overall performance of the system. Silence. Since solid-state drives do not contain moving mechanical parts, they are inaudible, thus contributing to a more pleasant and less disruptive working environment. Reliability. Improved reliability is another benefit of using SSDs. The failure rates of SSDs are lower than those of HDDs, largely due to the absence of moving parts. This not only contributes to the durability but also to the overall reliability of the storage device over the long term. SSDs can also undergo performance scaling. Taking into account ever-increasing storage density and advances in flash memory chip technology, SSDs can achieve high capacities while maintaining high performance. But there are some downsides that come with SSDs. The biggest disadvantage of an SSD is the cost. SSDs are more expensive than traditional HDDs. Because of their cost, SSDs are typically sold in smaller sizes. Also, data on damaged chips may not be recoverable. Though this is considered an advantage, in terms of data security, permanent data deletion could lead to irreparable consequences in certain events where there is no backup for deleted data. The SSD write and erase cycle is limited. An HDD can stand up to 1 to 5 million write cycles, whereas an SSD averages 100,000 cycles, meaning a decrease in SSD performance over time. This limitation in write cycles causes more trouble as it causes the SSD to decrease in performance over time. The emergence of SSDs has, without a doubt, revolutionized the way we store and access data. With their lightning-fast speed, strong durability, and energy efficiency, SSDs have transformed the computing landscape. So what's your take on this? Let us know in the comments section below. Thanks for watching this video as always. Make sure you like and subscribe to the channel for more amazing content just like this.